Hello everyone and welcome to our presentation. Here's the agenda. I will go through the project description and literature review, and Sun and Agatha will go through methodology and data, the analysis of results, the final product, and conclusion and recommendations. Our project consists of helping a hotel company that owns resorts and city hotels to gain further insight into their future revenue between the third week of July 2017 and the fifth week of August 2017. They want to understand the potential variables that would have an impact on the resort hotel's weekly revenue. The data set of the company was retrieved from Kaggle, and it ranges from July 1st, 2015 to August 31st, 2017. The objective of this project is to provide an Excel file containing 5 basic forecasting models for both branches, accuracy metrics, and a simple linear regression analysis that helps in explaining the variation in weekly revenues for the resort hotels. I will first go through the literature review section of our project so we can get a better idea of the types of research that has already been done on the topic. This first paper studies the best forecasting techniques to be considered for forecasting a hotel's daily demand with complex seasonal patterns. The authors compared different forecasting methods and their accuracy. They did not use traditional forecasting methods like we did in our study because their study was too complex. They studied the data from a Portuguese 4-star hotel with 300 rooms of 3 types: classic rooms, deluxe rooms, and suites, from January 1st, 2011 to February 25th, 2005, using 6 different forecasting techniques. Comparing the accuracy results across segments, they observed several inconsistencies. Using the MAP measure, they noticed that the double seasonal hot winter method was the most accurate for classic rooms time series. The same day of last year method was the most accurate for the deluxe room time series, and that the TBATS method was the most accurate for the suite time series. Results showed that the hot winter method was the least accurate method overall, both for all segments and all forecast horizons. And using the RMSC statistic, they noticed that the same day of last year and the double seasonal hot winter were more accurate than the TBATS for longer forecast horizons. Finally, the authors have concluded that the TBATS method is a promising tool to implement in a forecasting framework in revenue management systems. Now I will go through the second article of our literature review. The authors of this second article forecasted the demand for a 5-star hotel in Ankara, Turkey, using 149 monthly series of data from 1990 to 2002. Similarly to our research, they compared forecasting methods such as moving average, simple exponential smoothing, halts, winters, exponential smoothing, and ARIMA using errors methods. The operation was carried out in 3 steps. First, a list of 40 variables was put together and rated for importance by a panel of experts, from which they picked the top 25 variables. Second, they used winters, decomposition, moving average, ARIMA, and regression to smooth the data and calculated the corresponding errors for each technique. They noticed the highest accuracy from winter seasonality adjustments. Then the quantitative portion of the study was complemented by a qualitative study, which is an adjustment to the forecast. And they concluded that there are limitations to quantitative forecasting methods used in hotels because there are many factors which affect demand in hotels, and it is difficult to gain access to all information on all the factors. And the best way to maximize forecast accuracy is to integrate both quantitative and qualitative methods for forecasting. Now I will go through the advantages and disadvantages of the forecast accuracy metrics. First, the mean absolute deviation is a scale-dependent metric, which means that we cannot use it to make comparisons between time series which have different units. However, it is the easiest method to compute and explain. The mean square error is a metric similar to MAD. The major disadvantage of this method is that it puts more weight on large errors. The mean absolute percentage error is the only scale-independent metric. Because of that, it is a widely used method for checking forecast accuracy. The disadvantage of MAP is that it becomes infinite if the actual value of y is 0 for any observations in the data. It also puts a heavier penalty on negative errors than on positive errors. Taking into consideration these disadvantages, we've decided to use MSE and MAD for our project, as these are simple methods to compute and explain.
Now I'll be going over the methodology and data portion of a project. In terms of the source of our data set, it was retrieved from Kaggle, which provides booking information for two types of hotels. You have city and resort, and the data ranges from July 1st, 2015 to August 31st, 2017, which is a total of 129 weeks. For the forecasting models, we use weekly revenue over time, and for the multiple linear regression, we use as a dependent variable weekly revenue, and for our independent variables, we use weekly number of guests, length of stay per week. So this includes weekdays and weekends. And finally, the interaction between the weekly number of guests and length of stay per week. In terms of the data preparation of forecasting methods and the multiple linear regression, we aggregated the daily average revenue on a weekly basis. So in addition, as the raw data did not have a column representing the appropriate week number, we created one by using a nested if function with a column representing the day of the month. So the preparation was completed through the use of the Power Query function in Excel. And to determine whether there was seasonality in the data, we decided to create a chart containing a trend line for both resort and city hotels, as you can see in both figures. So in this case, the x-axis was indicated by the year, month, and week number, and the y-axis was indicated by the weekly revenue of the respective hotel. As there was an upward trend in both charts, and the weekly revenue appeared to be the highest during any given year in August and at the lowest between the weeks of November and January, we determined that there was seasonality in the weekly revenue of both hotels. For all of the basic forecasting models, whether it be 3, 4, 5 points moving average, simple exponential smoothing, and Holt's two-parameter model, we use the formulas provided in the production and operations management as well as the supply chain management textbooks. So additionally, these calculations were done in an Excel file. In order to deseasonalize weekly revenue, we found the weekly seasonal relatives by computing two center moving averages, one for 52 and one 26 points moving average. So after finding the seasonal relatives, we ensured to adjust it so that its sum equal to the number of seasons. We then deseasonalize the weekly revenue by dividing it by the respective seasonal factor. To determine the forecasted value in all of the basic forecasting models proposed in this research, we first use the deseasonalized demand to provide the initial forecast, then we reseasonalize the forecast by multiplying it by its seasonal factor. In terms of the simple exponential smoothing, we determine the smoothing constant by minimizing the mean square error, otherwise known as MSE, through the use of trial and error. And finally, for Holt's two-parameter model, we determine the smoothing constant by minimizing MSE through the use of solver. So the objective was set to minimize MSE by changing the values of the two parameters, so alpha and beta. And the two constraints that we used were that the two parameters needed to be greater than or equal to 0 and less than or equal to 1. For the multiple linear regression, we had to prepare an Excel file to aggregate all three variables on a weekly basis. We then imported this file into SAS. In terms of the data selection, we decided to perform a multiple linear regression analysis on the resort hotels as the average total revenue and the total deseasonalized revenue was over 50% below the city hotels. So in turn, this would allow us to potentially discover the predictor variables that would explain the variation in the company's weekly revenue for resort hotels. Now I'll be going over the model selection for the multiple linear regression. So we selected the appropriate model through the use of the best subsets algorithm. So more specifically, we took into consideration 3 criteria: adjusted R-square, Malal CP, and Schwartz-Bayesian SBC. So this figure shows that there were two subsets that could be further investigated, a model with the predictor variable weekly guess and one with the interaction term weekly guess and length of stay. So when we compared the adjusted R-square, both models had similar results. So based on the CP criterion, the model with weekly guess as a predictor variable showed a smaller bias compared to the model with the interaction variable. Well, lastly, when we analyzed the SBC criterion, its value was minimized for the model consisting of weekly guess. So based on these criteria, we decided to perform a Box-Cox transformation solely on the predictor variable weekly guess.
Let's go over the Box-Cox model transformation now. After performing a Box-Cox transformation in SAS, we concluded that the convenient lambda equals 0, which you can see in the figure on the left. That being said, we can easily compare the R-squared and the MSE between two models. The first one would be with the original data, where weekly revenue is regressed on the number of weekly guests, whereas the second one would be with the transformed data, where transformed weekly revenue is regressed on the weekly number of guests. As you can see in both ANOVA tables, the R-squared value for the transformed data equals 0.19, which is considerably bigger than the one for the original data, which equals 0.05. As for the MSE value, as expected, it has gone down after transformation. So, based on the model selection and the Box-Cox transformation, the ideal independent variable is the weekly number of guests. That being said, we decided to test the underlying assumptions of this new model to determine if it would help to explain the variation in the weekly revenue of resort hotels. All of these assumptions are shown on the slide. The first one being that the relationship between the dependent and independent variables is linear. The second one, that the disturbances have constant variance. And the last one, that the disturbances are normally distributed. We also assume that the error disturbances of the transformed model are not autocorrelated. After testing all of these assumptions, we concluded that only the assumption of the constant variance has been violated. In other words, the error variance is not constant.
Agatha and I will now be going over the analysis of results. If we look at the basic forecasting models in terms of MAD and MSE, for city hotels, the figure on the right shows that the 3-point moving average has the lowest MSE. However, the MAD for the 3-point moving average is 0.28% greater than the 5-point moving average, which has the lowest MAD. If the company were to rely on a basic forecasting model, we would recommend the 3-point moving average because the value of its MSE is significantly lower than any other method. For resort hotels, the 3-point moving average has the lowest MSE. However, the MAD for the 3-point moving average is 8.8% greater than the 5-point moving average, which has the lowest MAD. Thus, we would still recommend the 3-point moving average because the value of its MSE is significantly lower than any other method. In terms of the tracking signal, the figure on the left provides the forecasted revenues and the tracking signal for the city and resort hotels between the 3rd week of July and the 5th week of August 2017. For city hotels, the absolute value of the tracking signals is inferior to 4. In turn, the proposed forecasting method can be considered accurate. However, for resort hotels, the tracking signal is greater than 4 during the 3rd week of August 2017 at 4.23. So consequently, this model needs further examination and potentially a more advanced forecasting method such as the Holt Winters or the ARIMA method should be employed to ensure the accuracy of the forecast. Moving on to the revenue. So for city hotels, the revenue is significantly lower during the 3rd week of July and during the 2nd and 3rd week of August compared to all other weeks. For resort hotels, however, the revenue is significantly lower during the 3rd week of July compared to the other weeks forecasted.
For the simple linear regression analysis, we concluded 3 things. First, we used the best subsets algorithm and the Box-Cox transformation to determine that the independent variable that contributed in explaining the variation in weekly resort revenue was the weekly number of guests. Second, in terms of the 3 assumptions of the disturbances, both the linearity and normality assumptions were respected. However, the constant error variance assumption was violated. Consequently, we concluded that this violation would have an impact on the proposed regression line and on the accuracy of the prediction model. Lastly, we believe that the independent variable weekly guests is not the best variable to explain the variation in weekly revenue of resorts. but it is a good starting point, and we recommend additional research based on the variables that are not used in this project.
Agata and I will now be going over the final product of the project. I'll be going over the deliverables and their added value. So the analysis of the simple linear regression indicated that the independent variables weekly guests served as a good baseline in explaining the variation in weekly revenues for resort hotels. We provided also an Excel file where we calculated the weekly revenue of both city and resort hotels. But this information was used to create a line chart, which allowed us to uncover seasonality in the data. This graphing technique could be replicated by the company if they open other branches and they want to determine if seasonality exists. We also provided basic forecasting models, so whether it be 3, 4, 5 points moving average, simple exponential smoothing, and Holt's 2-parameter model. That could easily be modified to include additional data. The alpha of the simple exponential smoothing and the alpha and beta of the Holt's 2-parameter model could be modified to minimize other forecasting metrics such as MAD and MAPE. Accuracy metrics such as MAD and MSC and the tracking signal were included for each model. And finally, a template for SAS on how to perform model selection, Box-Cox transformation, simple linear regression, and testing the assumptions of the disturbances are all provided. This could be replicated for any other data sets.
As for the selling points, we decided that this product would be targeted to any company that is seeking to have a framework to provide an inexpensive and reliable forecast of their future revenue and a blueprint on how to include predictor variables in the model that have an impact on the variation of the dependent variable. Let's go over the conclusion and recommendations now. Because the absolute value of the tracking signal is inferior to 4, we can conclude that the 3-point moving average for city hotels provides an accurate forecast for an 8-week time horizon. In contrast, the 3-point moving average for resort hotels does not provide an accurate forecast because the 3rd week of August 2017 has a tracking signal exceeding 4. The simple linear regression analysis indicates that the weekly number of guests is not the best variable to explain the variation in the weekly revenue of resorts, but it is a good starting point. Now, based on our analysis, we recommend the company invest in creating a more advanced forecasting model, such as Holt's Winters or Arima for resort hotels. The revenue is significantly lower during the 3rd week of July and during the 2nd and 3rd week of August compared to all other weeks for city hotels. Therefore, we recommend the company increase advertisement during that period to increase occupancy rates and in turn increase revenues. Based on the simple linear regression model, we suggest the company add additional independent variables that could potentially explain the variation in weekly revenue for resort hotels. These variables may include the type of customer, his country of origin, or even the room type. Okay, we're going to wrap up our presentation here. Thank you for listening. These are the references used in our project. If you have any questions, do not hesitate to reach out to us. We'd be happy to answer all of them. Thank you.